Now, what we're doing with this here is we're finding the equation given the information. So we're given information about the parabola or this quadratic, and we want to find the equation that it goes to. Now, there's only two main equations that we'll have for this here. One of them is going to be in vertex form, and the other is going to be in intercept form, because those are going to be our two main equations. So we're either going to have it in the form of y equals a times x minus h squared plus k, or y equals a times x minus p times x minus q. If it's in vertex form, we're going to have a vertex, which is the point h comma k, and a point. So if we're going to use vertex form, we're going to have the vertex and a point. If we have the vertex and a point, we're using vertex form. X-intercept. If we're given the x-intercepts, p is equal to and q is equal to, or p comma 0 and q comma 0, and a point, x comma y, then we're going to be using intercept form. Now, I put the point on your note sheet as x3 comma y3, because really what we could say is that one of the x values is x1 comma 0 and x2 comma 0. It's just a way to name a point. If we're given two x-intercepts, or essentially 2 points where the y value is 0, that's the x-intercept, and a third point, we're using this form. If we're given the vertex and a point, we're using vertex form. Kind of makes sense so far? Not too bad. I mean, it's a little confusing at this point, yes? Well, and the note sheet doesn't look like it's a little crazy, yes? It's a little more involved than any of the ones we've had so far. Now, we're looking at example 1, so we're right there on the first page still. So example 1, vertex is the point 3, 2, and it passes through the point 13, 8, yes? Which type are we going to use? Which one of those equations will we use? The vertex one, yes? So we can circle the vertex one. So the y equals a parentheses x minus h squared plus k. So we can circle that one. Because again, I made these, so it's like we're filling it in as we go, to hopefully make these make a little more sense. Now, what are the variables that we're going to be using in the general equation? So if we look at this here, because we have h and k and a, yes? X and y are a part of the equation, our input output, so we're not really needing to plug numbers in. Thank you. So x and y is our input output. We'll have those in the final equation. The main things that we're missing are the values of a, h, and k. So what are the variables that we're going to be using in the general equation? So a, h, and k. Those are ones we're going to have. And those are the ones that we'll need to find. Do we know the values of these, and what are they? So out of the three, we do know two in particularly. We know h and k, because h and k are the vertex. They're the values of the vertex. And they told us the vertex is 3, 2. So the value of h is 3, and the value of k is, so we can fill that in for part 3. Because hk and a is part 2, part 3 right there at the bottom. Oh. Yeah. So this is part 3. Really, part 2 was a, h, and k are the ones we're using. And again, when y'all actually start doing this here, you do it on the homework. You're not going to have to write all this out. You're going to have to do all this. I'm doing this in this form to make it just as obvious as we can what we're doing step by step. So, looking at the equation here, yes? Y equals. Do we know what A is? No, but we're going to need to solve for it. That's the one we'll need to solve for. A, parentheses, X minus, well, we found H. H is, I'm going to plug it in. Just getting this far, you've pretty much got all the points except for one, which is the value of. So any questions on this so far? So we've used the vertex, yes? What's the only thing we haven't used? The point, yes? Because if this is a point on the graph, it means when I plug 13 in for X, 8's going to come out for Y, yes? If we simplify that side down. So what that tells us and what we can use is this equation here. Because what we know is that if I plug 13 in for X, Y's value is going to be 8. Because that's what an ordered pair of point does. Because if I plug the X value in, I will get the Y value out, yes? And what's the only thing we're missing? The value of, and that's what we're going to do. We're going to plug that point in, solve for the value of A, and we're done. We plug it back in. Now at this point here, okay, apparently both sides of the pin. Well, 13 minus 3 squared, we can do that all at once. Because I could type that in a calculator, and it would be 100. If we stepped it out, 13 minus 3 is 10 squared. 10 squared is 100A. Yes. Any questions on what we've done so far? I know we've gone back to Algebra 1 stuff, yes? Now we need to get A by itself, so the first thing we can do is subtract 2 from both sides, which tells us 6 is equal to 100. Then we would divide both sides by 100, which tells us A is equal to, well, 2 will go into both 6 and 100, which reduces 6 to 3 and 100 to 50. Really, we could have just stuck that in a calculator. 6 over 100 and it would give us the solution. Questions on this so far? So what that's telling us, so Y equals, because what we were missing before was the value of A. We have it as 3 over 50, parentheses, X minus 3 squared plus 2. And that's it. That's all we're doing with this here. Questions on this here? Now again, we don't have to do this all the way stepped out every single time. I drew this out probably a little painstakingly long to make sure we knew exactly what we're doing. Because this stuff here, because I don't like saying this because a lot of this stuff is pretty simple, yes? This is sometimes what students find to be the hardest stuff to cover because it is, there's not really anything to it. So it'll end up making it harder than it needs to be. Because really, if we look back at this problem, all we did was plug in the values of H and K. Then use the point for X and Y to solve for A. and plugged A back in. That's all we did. So are we good with that there? Yes? So let's look at example 2. Which of the two forms are we using? Right, the vertex form, yes? Because it kind of, exactly, it kind of gives it away. It tells us it's so we're using vertex form. And the variables that we'll need to find are the values of A, H, and K. Now we know what H and K are. H is -5, so we have negative 5 plus 9. But the negative and negative would make a positive. So what we have so far is this here. And really I skipped over part 3 saying that H is equal to -5 and K is equal to 9. Because I think we get this, yes? So really we can move over to part 4. Because we need to solve for A. Now, we use this point here. We plug in -7 for X and -15 for Y, telling us -15 is equal to A times -7 plus 5 squared plus 9. And we just need to solve for the value of A. Well, -7 plus 5, or 5 minus 7 is -2 squared, yes? -2 squared is, try again, +4. And that's always something, especially for the ACT, to be aware of or kind of paying attention to. Because if we have something in parentheses squared, it's going to be positive. So if you're working on a distance formula, because the square root of two things means squared added together, what's inside that square root for the distance should never be a negative number. Because both numbers are coming out of a square, it should be positive. Now we would subtract 9, telling us that 4A is equal to, divide by 4, telling us A is equal to -6. Plug it back in, it tells us Y is equal to -6 times X plus 5 squared plus 9. Questions on this here? Not too bad. We're ready for the next one. X-intercepts are -7 and -3 and passes through the point -2, 0.05. Is this going to be our vertex form? No. Equals A times X minus P times X minus Q. So that's the one we would be using. Well, what are the variables that we are using in the general equation? Well, P, Q, and A. As the three variables we'd be using are P, Q, and A. Because I'm just going to walk us through just the step-by-step what we have here. Do we know what the values of any of the variables are? Well, Q is -3. Even if they're given to us as a point, -7, 0, and -3, 0, it's still -7 and -3 because we're just pulling them exactly as they are. Okay? And I believe that gets us to the next page, yes? All right, now we can plug them in. Because y is equal to a times x minus negative 7 times x minus negative 3. Well, in both of these cases, the negative and negative makes a positive. So we get this here. But again, we still need to find the value of a, yes? Again, at this point, it's going to be the exact same as the last two because we're given a point, yes? So what that's telling us is that it passes through this point. So when y is 0.05, the value of x is negative 2. But how many places do we have x this time? 2. We plug it in both. Negative 2 plus 7 times negative 2 plus 3. Now we're going to solve for a. And that's it. Now I'm going to step this out one part at a time, but really, could we type that entire thing into the calculator? Yeah, it's all numbers. We can't put the a in. Don't put the a in either the graphing or the other one, because the TI-84 Plus, the graphing calculator, needs a value for that one. For any variable we put in, it wants a value if we're trying to calculate. But here, it can do parentheses negative 2 plus 7 times parentheses, parentheses, negative 2 plus 3, close parentheses, enter. It'll give us a value. Because if we did this by hand, we'd have 5 times 1. And 5 times 1 is 5, so it's 5a. And lastly, we can divide both sides by 5, and a is 0.01. Which tells us the equation is y is equal to 0.01 times x plus 7 times we like these here. Let's do at least one more of these, because I think it'll be good to look at one more. Now, looking at this one here, which one are we using? Which form? X-intercept, yes? Now, they didn't tell us that we had 2 x-intercepts. Because like the last one, it said the x-intercepts are these values, yes? But what's one key characteristic for an x-intercept? There's a 0 in the y spot. Well, yes, and for these here, how many points they give us? 1, 2, 3, yeah. Because they gave us 3 points, and yes, also. But because the other ones, they only gave us 2 points. Even if we didn't read what they were, and everything else, they only gave us 2 points on those. These, they gave us 3. Yeah. Well, they kind of did with the 0, 0. So we're using y equals a times x minus p times x minus q. Well, we're going to be using a, p, and q, yes? But I feel like at this point, especially with plugging this in, y'all know where this is going to go, yes? Because what's the values of p and q? Negative 16 and negative 2. So really we have y is equal to a times x minus negative 16 times x minus negative 2, yes? Well, the negative and negative do make a positive. So all these steps out, again, you don't have to do these, especially on the homework. You don't have to do it this way, okay? Because I painstakingly drug this out just to drive home the point, what is everything connecting to? because I have had a good number of students that have gotten this completely mixed up. So I'm doing it this way, but I feel at this point, especially getting to this equation, we're good. Yes? Yes. Now, the only thing we need to do is find the value of A, yes? So we're plugging this in for X and Y. We're saying that 72 is equal to A times negative 18 plus 16 times negative 18 plus 2. And again, we could type this all into a calculator. So I could say parentheses, negative 18 plus 16, negative 18 plus 2. Gives us 32. 32a, yes. If I did this by hand, negative 18 plus 16 is negative 2. Negative 18 plus 2 is negative 16. Negative and negative make a positive, and it's 32a. Then we would get a by itself. How many times does 32 go into 72, if at all? Will it go into it evenly? No. So we'll need to reduce it, yes? And again, we could do this by hand and say, okay, 2 goes into both of them evenly, which would give us 36 over 16. 36 over 16 would reduce by 2 again, and then continue to do that. Or 72 over 9/4. So y equals 9/4 times excuse me. That's it. Questions on any of this here? And that's all we're doing for this year.